So we'll start and then, huh? I'm starting then.
Yes, sir.
Is
Yeah.
Yeah? Okay. So uh, uh, all right. So quick recap from the lecture uh, 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 before this. We talked about probability mass function and then probability density function, right? And then we also talked about Bayes rule, right? Uh, if you're not clear about any of these things, you can ask me. My idea is to kind of run through the course material fast and then finally come to problems, and so that we can actually start solving all the problems, and that's where the understanding becomes better. Okay, and in fact, the first week material is good, but as we proceed further in the course, when the distributions and the t-test and everything start coming, suddenly the course becomes much more interesting. Okay, so this is probably one of this particular course has been my most favorite, in a way that I learned a lot from this, because though I had learned statistics earlier, I had forgotten everything. Moreover, I had never gone into such kind of depth while learning it. So this time it's kind of different, right? Uh, um, uh, so we're going to uh, the idea is to have good fundamentals on stats, because that's going to become the basis for your whole of data science and big data analysis and everything. All right. So you got any questions about probability mass function, probability density function, or Bayes rule, etc.?
I have to go through it,
Nothing.
yeah. It's-
So, but if you don't understand that, will you be able to? I mean, if you haven't gone through lecture one, lecture two might be a bouncer then. This is another thing about this course. You can't miss a single lecture. I mean, even if you miss the lecture while coming to class, make sure that you've attended the video, right? So, or are you aware of these things? How do I? So, if I proceed, then let's see. Anyways, so
Yes.
okay, so there are some properties to probability that we talk about. Let me see if I can show you those slides then, first of all, right? The previous week stuff. Mm, and notes. So let me quickly run through this. Uh, so we're saying what's the need for statistical inference? We are kind of clear about that. That when you don't have the whole of the data with you, you want to use uh, inference as a way to come up with a conclusion. Okay, and uh, so remember this, we're talking about a statistic. Okay, what is a statistic? Basically, you're saying that you have random data, okay, random variables, and you do some computation. For example, if I take the mean of the data, right? So I'm doing some computation. So this is what is called a statistic, and a lot of the statistics is about these statistics. All right, so singular is a statistic, okay, which is basically a computation. Okay, and this creates more random variables. Okay, and then you have frequentistic and Bayesian inference. That's just a definition. Okay, and so then the one is this to be remembered, right? Probability of uh, an event A happening or an event B happening is the probability of event A independently plus the probability of event B independently minus the probability of event A and B both happening, right? So basically, it's like a Venn diagram thing here. Okay, so and then we said that random variables are discrete or continuous. Okay, this will give us a probability mass function, and this will give us a probability density function. Okay, and from the probability density functions, as well as the probability mass functions, we create the cumulative density functions. Okay, whereas say, so probability density function is about probability, actually doesn't have any value individually, but say, when you create the cumulative density function, that's about what is the probability of a value less than where at that particular x-axis, all right? So up to that point basically, right? So it's the probability of x less than equal to x, all right? So basically, for example, it could be say minus infinity to x or say 0 to x. Okay, so integral of probability density function is the cumulative density function. So if you look at some of the examples here, uh, uh, let's say if we have a probability density function, say which is so what is one property of probability density function? One is that it has to be above 0 on the y-axis, and secondly, the area under the curve should be equal to 1. Okay, so let's say this is what my probability density function is, for example this, right? So I have the values on the x-axis going all the way from 0 to 2, and therefore the x-axis will be up to 0 to 1, sorry, y-axis will be 0 to 1, because the area of the triangle is half of x into y, right? And similarly, I could have another PDF wherein I say this is how it is at the value of 1, below 1 it is 0, and at 1 suppose it is half. Then if I say, if the slope was to keep on going like this, and if I have to fulfill the criteria that the area under the curve should be 1, then I can get the value of x, right? So this is what I can this is the mathematical part of the probability density function. Okay, so similarly, let's say, so if this was my probability density function, then the cumulative density function will be the integral of this, right? So if this is x by 2, y is x by 2, and then my CDF would be x square by 4, right? So just to give you an idea, so you can do, plus you will have the limits, so you'll have to take care of the limits. Okay, uh, so you have to take care of the limits here. Okay, so now what do you mean by the quantile, right? So basically, we say, if I say, look at this, for example, right? I say 50% of the area under the curve, right, is at which point, right? So 50 is like basically 50 percentile, right? So that's a quantile. Or I say 27% of the area is where, right? Or say I say 0.967% portion of the area is where. So that's what is called a quantile. So quantile will be in terms of the proportion of the proportion from 0 to in fact is not necessarily 0 to 1, it's like the proportion, right? And then that kind of gives you the probability. Okay, so we will look at this into detail, because everywhere it is either probability or quantile that we will play around with. Okay, so in a way you can say this is how it is. So quantile v of a cumulative density function is the point xv at which cumulative density function has value v, right? So if I say quantile is zero point 0.5, right, then v of a cumulative density function is the point xv. So I say on this graph, right? So if I say my quantile is say 1, okay, if quantile is 1, so what is the corresponding value, right? So that's how it goes. So we will look at the examples on R, and that will become more clear. So v is basically a fraction with particular numerator, right? uh, so with numerator is equal to particular quantile and denominator is equal to number of quantiles, right? So for example, I say say cat is basically into percentiles, right? So I say 99, right? So which means the numerator will be 99, whereas the denominator will be 100, because I've divided into 100. So that's how it is, right, typically. So uh, uh, that's just some definitions. Okay, so now now this is another key important concept. We say that we have the population, okay, and we have no idea about the population, what it looks like. We just have an idea about maybe the mean or something. At times, sometimes we know about the population, sometimes we have no idea about the population. We can just observe some data out of the population, okay, and that gives us an idea about the population. Okay, but for that we need to have some assumptions made. Okay, so typically what happens is, say for example, if I want to find out the population mean, I would call it the estimand. So it is the actual value, but it's the unknown value. So I would use the sample mean or the sample median, let's say, right? Population median versus sample median. Similarly, population mean versus sample mean. So, and that's going to be the called the estimator. Okay, and this is where the probability comes in, because if it is the estimand, then it's the actual value, and there's no question of probability, there's no question of randomness, nothing. But because we are talking about samples, that's why we're saying that there's a question of randomness. Okay, and then conditional probability simply is the probability of event A occurring given that probability b has event b has already occurred. Okay, and this is the way it goes is that it is probability of a intersection b divided by probability of b. Okay, and so similarly I can reversely write it that probability of b given A is similarly probability of A intersection B divided by P of A. And this is going to be, so if I use these two equations here, I get the Bayes rule, which is probability of event B happening given the event A has already happened is equal to probability of event A happening given the event B has already happened into independent probability of B divided by independent probability of A. Okay. So now what I can do is say, let's say probability, I want to find out the probability of event A. Okay. Now it's an individual event. It has nothing to do with the event B, let's say. Okay. Now what I say is, wait, you guys can't see the full written page screen. What do you mean by that? Can you guys see it now? I think you can speak back in the microphone, Pratik. If you have the head, all of you, I request you to buy a good quality headphone and a microphone. It will allow us to have everyone else also be able to speak, interrupt, and so feel free to interrupt me if you need to, just like in the classroom, right? So because mobiles off, please. Okay, okay, all right. So now what I'm saying is, let's say before event A has occurred, either event B has occurred or it has not occurred, right? So there is some probability of event A occurring after event B has occurred, and then there is some probability of event A occurring after event B has not occurred. All right. So if I add those two probabilities and and also take the probability of event B occurring and probability of event B not occurring, I would that will come back to probability of A. So basically, I can say probability of A is nothing but, if I was to expand it and include it in terms of probability of B, I say it is equal to probability of A occurring given probability of event B has happened plus into probability of B plus probability of B not occurring into probability of A occurring given that B has not occurred. Right? So is this clear? Is the equation C that I have written here clear to you guys? So this becomes the basis for all the tests that are performed. For example, you go through a medical test, right? So the basis of the medical test is this equation and then the Bayes rule. So are you clear about the equation 3?
Yes, madam.
Okay, right. Uh, all right. So I'm not going to expand this formula for now. Okay, I can leave it so basically it's as simple as this. I say that do you want me to go through this? There is, I think, a question also related to this in the quiz, but actually it is about using these equations. Let's say D is an event that patient has HIV, okay? Plus is an event that patient tested positive. Now understand the difference. Now somebody goes for the test. We don't know whether he has HIV or not, right? But the test will tell us whether he has HIV or not, right? So which means, so let's say, so we have two different events, right? So event D is whether a person has HIV or not. Event plus or minus are whether the patient tested positive or not. Understood the difference between the two? It is not necessary that somebody who tested positive will also have the disease. Similarly, it is not necessary that somebody who tested negative will also have the disease, right? So now, if I say probability of positive given that the person actually had HIV, right? What is that probability called? It's called sensitivity. All right. So we say the word, how sensitive is the test? All right. More sensitive it is, better the results are, right? And so this probability of plus given D is given event D is can be written as 1 minus probability of minus given D, right? Similarly, so this is a positive result when the patient has HIV. Similarly, I say probability that the patient tested negative given that he actually doesn't have the disease, right? So that is the negative result when the patient doesn't have an HIV, right? And that's called the specificity, right? So the machines and the tests should be such that they should have high sensitivity as well as specificity. But typically you will always have a trade-off between the two. Okay. So let's say, assume that you are given this. You are given that if the patient is HIV positive, right? Uh, he will test positive, and that probability is 0.997. And we are also given that if he is not HIV positive, he doesn't have the disease, the test will show that he is negative 98.5% of the times. Okay, and it's also given that, say there are 1 out of 1,000 people who have the disease, which means the probability of any individual having a disease is 0.001, right? So now what I can do is, from this I can calculate this equation. I can say probability of not getting the disease or testing negative even when the person has the disease is 0.003. Similarly, the probability of testing positive when the person doesn't have the disease is 1.5%. From this, and given this, I can compute these equations, right? So if I have computed these, I can calculate any of these values. Like, say if I have five values here, right? If four are known to me, I can compute the other five, the fifth one, right? So I already know this value, right? And I know this value, and so on, right? So basically the value that I'm interested in is this. I'm interested in the probability. Now what am I interested in? I'm saying that the person tested positive. Okay, what is the probability that he actually has the disease? Without the test, the probability that somebody has the disease is 0.01 0.1%. Okay, so but what is this probability? That's what is of interest to me. Okay, so I can substitute these values in this equation, right? And I get the probability of uh, positive. I have the probability of the disease being there. Now the probability of positive also comes to me. I can calculate that. All right, I can use that and then the base equation, and I can fit in the values, and I actually get the value. So I get the final answer as roughly about 6%. So what has happened before the test, right? By default everyone is 0.1% chances of having the disease, right? After the test, given these values, if somebody tests positive, the chances of his having the disease has increased to 6%, which is basically 60% increase in the chances, right? Is this point clear to you guys? What has happened? Have you understood what has happened here? Raise your hands if you understood this.
Yes.
Okay, Lavita got it. Kameshwar got it. Pratik, Supreet, you didn't get it? Okay. So now probability of so like that, there are more definitions there. I'll not go through that. Okay, I would focus on the fundamentals here. Okay, so I can use, you can go through this yourself. I've sent the notes. Okay, so post test odds. So odds, basically another concept is to learn odds. What do you mean by odds, right? So I say probability of something happening is 1. Okay, sorry, let's say 0.25, right? The probability of it not happening is 0.75, isn't it? And when we typically talk about the odds, what we do is we take the ratio between the two. So basically odds of something happening is 0.25 and the odds of it not happening is 0.75, right? So or the probability of it not happening is 0.75. So basically I can say 0.25 divided by 0.75. So basically the odds are 1 is to 3. Is this clear? So that's how the, it's a different terminology. Okay, so I can use the terminology of odds as well. So typically it is used in betting. In betting you will not say probability of A and probability of not happening, but it is typically betting, odds that are used. Okay, all right. So know that when then A and B are independent, then probability of A and B both occurring is equal to probability of A into probability of B. Okay, so now another very important concept is IID, which is independent and identically distributed random variables. When you say independent, basically like say I toss the coin, right? And I toss the next coin. The next coin toss has the value that I'll get on the next coin has nothing to do with what value came in the first coin, right? So that's what the independence is about. Identically distributed means, let's say the coin is biased, which means 80% chances of I getting heads and 20% chance of me getting tails. So now first time I use that coin, next time I use another coin which has 50-50 chances of anything happening. So these two coins are not identically distributed, they have a different probability of different values coming. So basically identically distributed means the source is the same, of generating that event is the same. Okay, or generating the random number, variable is still the same. So that is what is called IID. Okay. So IID is typically is the assumption that we make when we deal with probabilities. Okay. We said no, from sample we determine something about the population, but for that we need to assume that whenever we are generating samples or generating random variables, they are IID. Okay. So so this is an assumption that is made. So what is the assumption that we make? One is that the samples are random, and secondly that the variables that we get out of these samples are IID. Okay. So if we draw the if we toss the fair die many times, that's a sequence in IID. Okay. And if there's a loaded die again which is thrown many times, it will still be a sequence in IID. So all right, so this was from the previous class. Okay, so coming to today's class, and then we will look at the examples and other things. uh, All right, so what we're going to look at is expected value, right? So I'm just going to quickly run through the slides, and then we'll look at the examples and they'll become better. Okay. Uh, so why do you need the expected value? So basically, it is useful for characterizing a distribution, right? So mean is a characterization of its center, and then the standard deviation is the characterization of how spread out it is, right? So that's the whole idea. So we have the mean and the standard deviation. Uh, so basically, we say so I have some distribution. Okay. So now this distribution has some center point, right? Let's say call it mu. Now this distribution could be like this, or I could have another distribution. Now this distribution has another central point, or I could have another distribution. This has another central point. But what about this? So this tells me about the spread of the distribution. So I could have same center point, but the distribution could be spread narrowly or more widely. Is this clear? So the spread will be determined by the standard deviation, and then the average is determining the mean. Sorry, the mean. So I would call this as the first statistic, okay, the mean, and then the spread as the second statistic. Okay, all right. So what are we saying? We're saying that our sample expected value, say let's say I take 100 samples, right? 100 values of the sample, they will estimate the population versions, right? So I was talking about that as a population. So my sample will actually have some mean and standard deviation, right? So the idea is to estimate the population mean and standard deviation from these values. Okay. So what, so the expected value or mean of a random variable is the center of its distribution. It's nothing but, for example, if it was a probability mass function, let's say for example the rolling of a die, right? The probability of getting any value, let's say 1 or 2 or 3 or 4 or 5 or 6, is 1 by 6, right? And then each of these values are there. So I say 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 and so on. So I get the expected value of the roll of the die. The expected value is 3.5. Now does 3.5 make sense when I roll the die? It doesn't really, right? Because you will never get 3.5. You will either get 1 or 2 or 3 or 4 or 5 or 6. But what is expected value telling me? It's kind of telling me the average out, right? It's like the center of mass. Assuming that I had locations and weight, right? X is my location and the probability is the weight. So I get the center of mass, right? So, so for example, so he's just done some plotting here, okay? Uh, let's look at this, right? Say I do the coin toss, right? So I get a 0. Let's say I assign tail to a 0 and a head to a 1, right? So I have 50% probability. Now the center of mass of these two values will be somewhere in the middle, right? If I was to actually do it physically also geometrically, it will be somewhere here, so it will be 0.5, right? Similarly, if I have a biased coin, right, where the probability of getting a heads is p, then and therefore the probability of getting a tails is 1 minus p, my center of mass will be given by p. All right, 0 into 1 minus p plus 1 into p. Okay. Similarly, rolling a die, so what happens here is 3 here and 3 here, right? So my center of mass comes out to be somewhere here, isn't it? So that becomes 3.5. So this was about the discrete variables, discrete random variables. What about continuous random variables? So for continuous random variable, the density with density f, the expected values again exactly the center of mass of the density. So even there it's the same. Okay. So the only difference is now that we will take the integral. Okay. So we have, so let's say consider a uh, probability density function which is given by fx is equal to 1 for x between 0 and 1, and everywhere else it is 0. Okay, so this is what it is. So if I was to take the center of mass of this object, then again it will come to be zero point 0.5. Okay, so now expected values are properties of distribution. Why so? Because we actually create a formula there, right? So there's a formula associated with an expected value, and the average of random variables is itself a random variable, and its associated distribution has an expected value. Now this is an important point here. Is this clear? When we say we take 10 random variables, right? These 10 random variables, when we take an average, even that will be a random variable, isn't it? So if I was to take the random variables again, what will happen? My average will be different. Why? Because it's a random variable, right? And so basically the average when you take of the sample is itself a random variable. So the center of this distribution is the same as that of the original distribution. Okay, let's look at this. What does he mean? Say I have some distribution. Uh, Let me call it. What's the distribution that I'm looking at? Mm, let's look at. All right, so let's look at the population. Okay, the population in Orissa, and then I want to find out the height, average height of everyone. Okay, let me not use this. Let me use this. So I'm interested in average height. Okay, so now I'm not just. I don't know how it is distributed. It could be a normal distribution, the population, right? So or it could be any other distribution. Let's say it's distribution which goes something like this. Okay, and say this is 4 feet and this is 7 feet. Okay, and everything is uniformly distributed in between this. Is this clear? So it doesn't matter how the population is distributed. Now what I'm doing is I don't even know. Let's assume that I don't know what's the distribution of the population. It could be 1 or 2. Now what I do is, assuming that I don't even know what the population distribution is, I take 10 samples out of that population distribution. Okay, let me call the population distribution as f of x. So I take 10 samples out of this, and I let me denote them by some x1. Okay, so I take an average of this. I say x1 average, right? So I denote it by this. So this is what I get. Now, because there are so many data points, let's say in my population has, let's say, a million data points. So I took 10. Okay, so my n is 10, and I take another one, another set, and I get x2 bar, right? So I had x2, which gave me x2 bar, and so on. Now these x1, x2, x3 bar, right? All of these, there's a distribution associated with these also, right? So if I was to keep on taking these samples, I would get a distribution. And what are we saying here? No. So we're saying the center of this distribution is the same as that of the original distribution. So now I get a new distribution, and let me tell you, this new distribution will be very close to a normal distribution irrespective of what our original distribution was. Okay, so now this distribution has a center. Let me call it x bar. All right, now this center would be the same. So whatever the value, let's call it, let me say that this value is equal to some constants c. All right, though it will not be a constant, it will be a variable. It would be nothing but, even this distribution will have the center here at c, either this or this. Is this point clear? So we're saying that the sample mean is an estimator of the original distribution's mean. Okay, so the expected value of the sample mean is the population mean that it is trying to estimate. Okay, so when the expected value of an estimator is what it is trying to estimate, we say that the estimator is unbiased. So when this happens, right, there are chances this may not happen, but we typically, whenever this happen, we say okay, it is unbiased. Okay, so so this is one key thing that we want to uh, uh, assume. All right, so we say okay, whenever this is holding true, wherever, okay, it is an unbiased. So what I'm doing is, so he's saying he's simulating normals with mean is 0 and variance is 1 versus averages of 10 normals from the same population. Okay, let's try to do this. uh, how do I quit out of this? Any idea? I'm not bothering to read the question. How many sides or
Where
faces does it die?
you take exit.
Exit?
You can type exit. Yeah.
It's not going. Mm,
Zero.
zero, I've tried. They're just how many sides or faces does it die?
But it's showing zero to exit.
Okay. Uh, yeah, but it's not happening. Uh, hopefully, it should go now. Oops.
भैया क्या ये कर रहे क्या?
Huh? How do I quit out of it? I'm not able to quit out of this. Swirl. Mm, let me just don't save, restart. Keep it simple. Okay, so didn't like it. So what am I trying to do now? Let's say, uh, or rather, let me go through the theory first, and then I'll come to the simulations, etc. Is that fine? Yeah. So let me just finish through the theory part. We'll come back to the simulations. Basically, let me just explain it right now here. What's happening is, let's say this is my observed values, all right, and I take the mean, and the means are observed. Sorry, the means are calculated, and I plot that. What will happen is that this is how, where it will get distributed. This the center is still the same, though the spread has changed. Okay, we will look at why the spread changes, etc. So so averages of x die rolls he's talking about. So multiple die rolls we are doing. Okay, uh, averages of x coin flips, so everything will center around zero point 0.5. So expected values are properties of distribution. First thing, the population mean is the center of the mass of the population, the sample mean is the center of the mass of the observed data, but the sample mean is an estimate of the population mean. The sample mean is unbiased, so we will assume that our sample mean is unbiased. Okay, the population mean of its distribution is a mean that it is trying to estimate. The more data that goes into the sample mean, the more concentrated its density is around the population mean. Okay, we will look at all of these things, okay, as we proceed further. So all right, so I will quickly go through the theory of variance, and once we are done with that, we are ready to take up some of the questions. Okay, uh, or let me just take a break and kind of solve these things for now. Okay, all right, so let's say look at this question now here. So or let me just do this. I think it'll be better that you've seen something happening. Let's say I generate, uh, are you aware of this functions like R norm? What is R norm doing? It is generating the number of random variables, right, specified with a particular mean and a median, right? I say mean is, let's say, 50. Okay, and let's say my standard deviation is 100. Okay, let me generate that as my data 1. Okay, is this fine? Are you with me on this? Okay, so now if I take the mean of data 1, What do I get? I get 51.0899, right? So basically it is close to the mean that I had taken of the population. So out of the population, when I took 1000 data points, I got a value which is close to what is my expected, what's my population mean. In this case, I knew the population mean. Are you understanding what we have done? We have simulated uh, uh, um, uh, data from a population which we know the mean of. Okay, let me redo this. Okay, so I say data 1, so I say mean of data 1. I get a 55 now. All right, so I keep getting different answers every time, but these answers are close to, so they are representative of 50. Are you getting this? So if I did not know, say if I just had to look at the data points, I say data 1, you see there are 1000 data points. So if I did not know, if I says I gave you these data points, I give you this array, you don't know where it got generated from. So what will you do to give me the mean of the values? You will just take the average out of it, right? And you say this is what the value is. Now when we do that, we are getting a value which is close to 50. Okay, what if I increase the size? So I say instead of 1000, let me take a million. Okay, or yeah, so I'm taking a million data points. Suddenly I have a mean. Let's keep doing this again and again. So I'm getting it more close to the 50 now. Are you getting what is happening? So my mean is closer to 50. Why? Because the sample size has become bigger. So that is why the spread reduces. Because so what is that spread about? When we saw something here, right? We Let's look at our slide one more time. Uh, uh, Look at this. So observation values have a different stuff here. But when we keep on taking the averages, we notice that we are getting some values here, which is 50 and so on. Now, if I was to plot these values, the 49.89, 49.96, that is going to be this pink curve. Is this clear? And the greenish curve is of the actual data. So basically, I'm retaking the sample again and again and again and again. I will notice that I get this kind of a curve. Is this part clear to you guys? Basically, this is also called, we will look at something called central limit theorem as we move ahead. But uh, uh, so is it kind of vaguely clear to you? Because this becomes the basis of all of our statistics. Have you any doubt? Please speak up. Are you guys there? Okay. All right. So when I see some movement happening, like for example, a hand raise and all, I know that you're there. So just raise your hands if you're there, if you understood whatever. Also, okay. So raise your hands if if you understood everything. Please raise your hands. Okay. Supreet, Lavita, Pratik, Dipankar, you understood things? Okay. Yeah. All right. So I have mic rights for you guys. Ideally, you should be having your mics on, unless there's some noise that's happening in your room because of somebody else. Uh,
No, but
yeah.
actually, there was a problem with my laptop. I couldn't even log in properly. So I was
Okay.
just being okay.
ठीक है. Huh? So, all right. So this is the thing here, right? So that's about, say, if we look at it, we have kind of covered what is the expected value, all right? And we will look at more topics after we finish the homework one part here, okay? So now let's come back to things that we want to do. Uh, uh, so this is the homework one part. So it says consider the uh, You can read my screen. So it says the epidemic has happened. Uh, so there's 50% probability that at least one of the parents has contracted the disease. Okay. So what are we saying here? We're saying the probability of A union B is 15%, right? The probability that father has contracted the disease is 10%. So probability of A is 10%, right? So it's a very simple silly question here. While the mother contracted the disease is 9%. So probability of B is 9%. So what is the probability that both contracted the disease, right? So we're saying, so 15 is equal to 10 plus 9 minus probability of A intersection B, which is both, right? So this answer is what? 4%, right? So we select this, all right? And then let's move ahead to the next question. So a random variable x is uniform, a box from 0 to 1 of height 1, so that its density is such. So which means it's something like this: 0, 1. So this is height 1, all right? What is its median expressed to two decimal places? Now notice that he's not talking about mean, he's saying median, all right? So so it's a uniform random variable, right? So uniform variable. So what is its median going to be? Come on. So what will be the answer here? Yeah. So 0.5, right? Because median is what? It is the middle value, not the mean. Understand? The mean is different from the middle value. So let's say there are 10 points that we have. Median would be the fifth and the sixth point, average of that. Hmm? So this is what my answer is, but I will still look at the median is the point so that 50% of the density lies below it. All right. So
0.50.
okay, now let's look at another question. So you're playing a game with a friend, and when you flip a coin, and if it comes up heads, you give her X dollars, and if it comes up tails, she gives you Y dollars. So here the question is odds, by the way, not probability. Okay, that the coins is heads is D. What is your expected earnings? So first of all, uh, when you say the odds of the heads to tails, so this is D, and this is going to be 1. Basically, that's how it is denoted. All right. And as I remember, I gave you the example of 0.75 and 0.25, right? So that is what D and 1 are equivalent to, right? So which means the probability of heads will be given by D upon 1 plus D, right? And probability of tails will be given by 1 upon 1 plus D. Is this part clear? So don't get confused with the odds part. Suppose straight away what was given to me was probability. Then I would have just used D and 1 minus D. But here it is
Okay.
odds. So that's what I use. Is this clear? Okay. So once I know this, so my probability of getting the heads is this. Okay. So if it comes heads, then I lose X dollars, right? So I say X into minus X into probability of heads. And board is not visible. Sorry, what is not visible? How come? Is my screen not visible?
Yeah.
Yeah.
Uh, s- the what you mentioned, you use the odds. That's why it's D and one Can you please repeat on how you got that? It looks simple, but I didn't get it.
Ah, all right, all right. Uh, See, what happens is just a terminology. Okay. Uh, when we say, um, let me just redo this. Okay. Let's say I have a probability of heads and a probability of tails. Okay. Let's say this probability is P. And I know that this probability is 1 minus P. Right. So now if I was to take the ratio between the two, okay, I say P over 1 minus P. Okay. And I denote this as some number. Let's call it D. Okay. So if I was to now have this as D, this is what is I would say is the odds. Okay. So probability is this. So if I say the odds of pH happening is D, but pH is coming from P into 1 minus P. All right. Then what is the corresponding probability? So if I was to reverse it, right, what happens? What is P in terms of D? I want to compute that. Okay. So P is equal to 1 minus P into D. So P is equal to D minus P into D. All right. So P into 1 plus D is equal to D. Right. So I can say P is equal to D upon 1 plus D.
Yeah.
Got this?
Yeah.
Right. So basically this is what I took. I took the ratio of this. So if P is equal to D upon 1 plus D, what is 1 minus P? Let us do that. Right. So 1 minus P is nothing but 1 minus D upon 1 plus D, which is nothing but 1 plus D minus D upon, sorry, did I make a mistake? Uh, yeah, 1 upon 1 plus D, right? So I get these probabilities. One is 1 upon 1 plus D, another is D upon 1 plus D. So instead of denoting things as P, I'm denoting it as D. So this was algebraically. Let's look at it how it goes basically. I say the probability of India winning the match is 25%, right? And probability of Australia winning the match is 75%, right? So I was to represent it as odds. What do? I say odds of India winning the match is 1 is to 3. Is this clear? So so normally I use this terminology. I say odds are 1 is to 3, which means the probability of India winning the match is 1 upon 1 plus 3 and probability of Australia winning is 3 upon 1 plus 3. Is this clear? So typically what happens is 1 is considered as 1. The other terminology, so basically we say odds are 3. So Australia winning the match is 3. The odds are 3. So this is not even told because this is considered as 1 anyways. So it's always 1 is to something. See, otherwise what is happening is it was like 0.25 versus 75%. I want to keep one value as 1. Corresponding to that will be the other value. Is this clear? What is why we use the term odds? And is it clear now? So here he's saying that the odds are D. So therefore, first of all, we'll get to the probability. You can only see the question. Board is not visible. Is it clear for other rest of you? Let's see what's the problem here. Uh, you
Fine
can see
for
the screen. Huh?
rest.
You can see my screen and whatever I'm writing with hand. Lavita, you cannot see what I'm writing with hand.
Yeah.
Lavita, you can't see. Oops. What is happening then?
I
Screen
can see
sharing.
everything, Bhaiya.
This is Kameshwar, right?
Yes, Abhay. Yes,
You
Bhaiya.
can see things that I'm writing.
Yes,
Who
and the
else? Who
question
all can
also.
see? Please raise your hands. Who all can see what all I have was writing now? The board is shifted to the left. What do you mean by board? What is the board here? It is my screen that I'm showing you guys. Sorry, what terminology are you using? You mean the one that I'm writing on? Maybe you have just check it out. Maybe the screen that you are seeing, you have kind of, it has stretched out beyond your visible area. Probably you need to pull it into your visible area, because will be unlikely that the transmission is happening such that to Pratik said minimizing chat window may help. Has that worked out for you? Okay, okay, good. All right. So this is what the odds are. So here, having said that, so what we do is we just compute this, and we'll find that the probability of me heads coming is d upon 1 plus d, right? And that's the money that I'll lose. And then the probability of tails coming would be 1 upon 1 plus d, and that's the money that I'll gain. So basically, this is going to be my answer. All right. And then let's move to the next one. So a random variable takes the value 4 minus 4 with probability zero point 0.2 and 1 with probability zero point 0.8. What is the variance of this random variable? So how do I compute the variance? First I can get to the mean, right? So my mean would be minus 4 into zero point 0.2, that's minus zero point 0.8, plus 1 into zero point 0.8, right? So that's minus zero point 0.8 plus zero point 0.8, that's 0. So my mean is 0. Okay. So now what's going to be the formula for my uh, random variable? Variance. It's going to be, say, xi minus mu square into probability of I, and then the summation. Okay, so in this case the summation is of two values. Okay, so I have mu as 0 anyways. Okay, so my xi is minus 4, so I say minus 4 square into probability of that happening is zero point 0.2. Okay, plus 1 square into zero point 0.8. So this becomes 16 into 0.2, 3.2, right? And this becomes 0.8, so that is 4. So my answer is 4. Is this clear what we did here? Okay, now this is interesting. Uh, I guess this will require me to give you some more theory before we move to this. And I think we'll do that then. Okay, so I think we've covered the questions so far associated with whatever we were doing. Let me just see if I can jump and see if there's another. Okay. All right, let's solve this. So consider the following probability mass function given in R. P is equal to this, X is equal to this. What is the variance expressed to one decimal place? So let's solve it in R itself. Okay. Uh, so what do we have here? So let's define P as C 0.1 comma 0.2 comma 0.3 comma zero point 0.4. All right, and then X as 2 to 5. Okay, so now I want the variance. So how do I go about the variance? First I take the average, right? So my average would be given by P into X straight away, right? So that'll give me the average. Basically I have to take the sum of this. So if I say sum of P into X, so I get the average as 4. So what I do now is I want to take the standard deviation. So how do I get the standard deviation? Variance. So I say x minus 4 square, all right, into P. Okay, and then I take the sum of this. Are you getting what I'm doing? I'll write it down and show it to you. Okay, so I get the value as 1. Let's see if that is correct. What did I do here? Same thing that we did here, exactly the same, just that I used R now. Is this clear? Have you understood? You got it? How we got the variance calculated? There are simple calculations. This just so that we kind of, for completeness sake, we are doing everything. Have you got it? Please raise your hands if you got it. Okay. Okay. All right. So, all right. So this part was okay. Good. Uh, so we'll come to the more interesting stuff as we move ahead now. Okay. What's the time now? Just 1 hour into the class, right? We can continue, right? Hmm. Okay. So now the new concept, the other concept that we have to learn is variance. Okay. So so what is variance? Variance of a random number x. And now, by the way, random variable can be discrete, it could be continuous, it could be neither of the two, or it can be mixed. All right. Is its second central moments? What the first central moment is our expected value, right? So so the expected value of the squared deviation from the mean. So what is it? Basically, it is the expected value of the squared deviation from the mean. We already computed it in the last cases here. But if we were to define it, we say mu is equal to the expected value of x. Okay. And variance of x is equal to the expected value of x minus mu square. Okay. So it's the expected value of this. All right. And at the same time, we can say that the variance of x is also equal to covariance of x comma x. Okay. If we were to expand this formula here, we know that mu is again the expected value of x anyways, right? So we get it as expected value of x minus expected value of x the whole square, right? So if we were to just do little algebra here, it becomes the expected value of x square plus expected value of x the whole square minus 2 into x into expected value of x. Okay. So so if we were to sum it up, this becomes like this. Okay. So it'll if I was to knock off all the maths in between, basically it becomes expected value of x square minus expected value of x the whole square. All right. So if we come back to our equation here, so this is, so what happens is this. Basically, if you look at this equation here, right? So know one thing. Let's just do a little bit of simple stuff here. Expected value of a plus b is equal to expected value of a plus expected value of b. Having said this, if I was to expand this, what happens? So it becomes expected value of x square plus expected value of x the whole square minus, so expected value of x square. So two expected values are not required because once you have the expected value, that will knock off this expected value, right? Minus, so 2 into expected value of x into expected value of x. All right. Now what happens here is this becomes 2 into expected value of x in another thing. Expected value of a into b is equal to expected value of a into expected value of b. All right. So these are the rules that are there. So this becomes minus 2 into expected value of x into expected value of x. And this is nothing but expected value of x. So this becomes minus 2 into expected value of x uh, whole square. All right. Um, so what happens is, so basically there is already one here and then minus 2 becomes 1. So effectively with the formula that we get eventually is this. So we get expected value uh, basically the variance is the mean of the squares minus the square of the mean. All right, so expected value of the mean of the square minus the expected value of the square of the mean. Okay, this is the formula that we'll keep on using as we move ahead. Okay, so for now just know that this is how it is. Okay, so let's look at, say, discrete random variables. Say x is a discrete random variable with the probability density function given here. So we have already done this formula in the example that we solved, right? We said it is equal to probability of xi into xi minus mu whole square and summation from I is equal to 1 to n. And when we expand it, by the way, it also becomes like this. I can straight away do it as xi into square into probability function minus the mu square. For example, let's go back to our previous case. Let's get to R. Okay, so what did we do? We did x minus 4, right? What if I don't do x minus 4? If I just do this sum of x square into p, right? And then this comes to 17. And if I subtract from this mu square, that is 4 square, I still get 1. Is this clear? So that's what is getting depicted from this equation here. Uh, so I can write the same equation mathematically like this as well. Hmm? And so now here in this slides there is a long example. I'm not going to go through the proof, algebraic proof. That's not needed because it will take a lot of time and we have lots to cover in this course. Okay, so but let's just look at the properties of variance. So variance first of all has to be greater than or equal to 0. Why so? Even if the mean is less than 0, still the variance has to be always greater than or equal to 0. Intuitively, not mathematically. Mathematically we know that it has to be uh, because it is a square number, right? We say x minus mu square and probability is always greater than 0, therefore it has to be mathematically greater than 0. But intuitively if we look at it, whatever the distribution, the spread will be such that it is always around the mean, right? Which, and that's what variance indicates, how much spread out it is around the mean, right? And therefore it's always greater than or equal to 0. So variance of a constant random variable is 0, and if the variance of a variable in a data set is 0, then all the entries have the same value. Understand this. So if a constant random variable has a 0 variance, what does it mean? It means that it has a strict fixed value. So which means that the probability that x is equal to a will become equal to 1. Only then the variance of x is equal to 0. Is this clear? Otherwise there is no chance of this happening. So variance is invariant with respect to changes in location parameter. Now I say variance of x plus a constant is equal to variance of x. How come? Why so? Does it intuitively sound correct? Or mathematically, even mathematically, do you think it looks all right? Suddenly then A has no meaning, right? Let's come back to our formula here, right? So variance of x is what? Pi into xi square minus mu square here, right? So if I was to add an A here to x, so what happens? For each of these values, a new value is getting added. But that much far away it will get from the mu, right? So the mu will change. Mu will also become mu plus A, right? So basically what happens is this. Uh, Let me explain it here. Okay. Uh, are you guys clear with that concept, or shall I kind of explain it? Let's say this is how the random number is distributed. Now, these are, so I get some values, right? So some sample values, let's say. If I was to add a constant value to each of these values, what will happen? So these values would have given me some mu, right? Average of this. What happens is when I'm adding a constant value to each of these, my mu also changes from mu to mu plus A. So what happens is the difference still remains the same. So if I say xi plus A minus mu plus A, so effectively A gets cancelled. So effectively I'm left with xi minus mu. So it doesn't matter. The variance will not change if I add a constant value to all the random variable values. Is this concept clear? So, so variance of x plus a is equal to variance of a. If all the values are scaled by a constant, then the variance is scaled by the square of the constant. Is this point also clear? If I say variance of a into x will be equal to a square into variance of x, because what happens is that variance is a square, right? So a into x will end up. So do I need to elaborate on this, or this is kind of fine with you? If it is fine, then just tell me, raise your hands. Okay. So just little bit is that when I say variance of a into x, right? So I'm saying variance of sorry a into x. So which is basically a into x. Let's assume mu is 0, right? Assume mu is 0 because it doesn't matter, right? We saw that from the previous example that we can have any constant value. Let's say we choose some constant value which allows that the mu to be 0. So ax square, right? So everywhere I'm going to do the summation into probability I, right? What happens is I can take this a square out, right? I say a square into xi square into probability of I summation, and then I can take a square out, and then this whole thing is left, which is nothing but variance of x. All right. So this is also done. Okay. So similarly, more general form is this. I say variance of a x plus by. What will that be? Okay. So this is fine. We have squared it up, right? This is a constant value. Nothing changes. Fair enough. What if we have two random variables, x and y? So now this is of interest to us. Okay, let's do this simply first for a simple case, and then we look at the more complicated one. I say, what is the variance of x plus y? So this becomes variance of x plus variance of y plus. So the way it works out is basically 2 into covariance of x comma y. All right, that's how the whole thing is. Okay, so we will not go to the details of this, but typically what happens is when the x and y are independent of each other, then covariance of x comma y is equal to 0. All right, and therefore what happens is the variance of x plus y becomes equal to variance of x plus variance of y. All right, so this is a fundamental thing that we will have to keep in mind. Know one more thing, that what happens is, what about the variance of x minus y? What will be that? Will it be variance of x minus variance of y? So I have an open question for you. If variance of x plus y is variance of x plus variance of y, what will be variance of x minus y? Are you guys getting me? Are you with me? Okay, perfect. Variance of x. So Kameshwar says it will be variance of x plus variance of minus y. Perfect. And what will be the variance of minus y? Minus 1 into variance of y? No. Another important thing. When we set this, right? Look, variance of minus 1 into x. What will that be? Minus 1 square, right? So, basically variance of x minus y is equal to same as variance of y, right? So what happens is, even though you take a difference, now understand, let's look at it intuitively. I'm saying that I add up the two random variables. The variance gets added up. Fair enough. In fact, the mu also gets added up, right? So mu straight away getting added up. So mu of x plus mu of y, right? But when I take the difference of the two, The mu is getting subtracted. I say mu of x minus mu of y, but the variance is still getting added up. Is this clear? Huh? So using these, so and I can generalize it. So I can say a square into variance of x plus b square into variance of y plus 2ab into covariance of x comma y. Now x and y, let's say if they are independent to each other, then this will become 0. Okay. So effectively all these calculations will finally lead me to variance of sums equal to sum of variances. Okay. So that's what the whole idea is. That and this is important because this will lead us to central limit theorem. So what am I saying here? I'm saying the variance of a plus b plus c plus d is equal to variance of a plus so on, right? So I can write variance of x1 plus x2 plus x3 and so on is equal to variance of x1 plus variance of x2 and so on, right? Now what happens if each of these, let's look at this interesting now, right? So I say if x1 is a random variable from the same population, all right, x2 is also a random variable from the same population. Okay, so this becomes variance of x1 plus variance of x2. But since they are from the same population and we know that the definition of variance is what? Expected value of x minus mu, all right, square. It's the expected value of this. Therefore, whether it is x1 or x2 is not going to matter. So what happens? Variance of x1 plus x2, in case they are similar from the same, just that the samples are different, will become 2 into variance of x. All right. So and so on, right? So I can just sum up my variances. So what I can do is, let us look at the variance of the mean. So we remember we saw that our graph was getting what was happening to our graph was that when we were taking the data points, it was coming out to be like this, and when we were taking the means, we were taking some sample, it was coming like this. So it was same, still centered around the same mean. The spread was decreasing. Why is the spread decreasing? What we are saying is, let us look at the variance of the mean. Now mean is defined by x bar, right? I say variance of x bar, variance of, and I can expand it. I say expand it to xi. Let's understand this for discrete values. We can easily understand it for the other ones. So I say it is equal to x1 plus x2 plus x3. Let's assume three values divided by 3. All right. So it is the variance of the summation of these three. So I can say this, that this is equal to variance of so this is equal to a, let's say, right? So this becomes 1 upon 9 into variance of x1 plus variance of x2 plus variance of x3. Is this clear? Are you clear with this so far? Are you, if you are clear with what am I doing here, and I'm not just talking to myself, please raise your hands. Okay. Now what I'm saying is that x1, x2, x3, each of these three are samples from the same population. Therefore, the expected variance of each of these is going to be the same, right? So I replace that with the variance of the population. I call it as the variance of x, which is the population, right? So now it becomes 3 into this, which was the actual number here. So 3 into variance of x divided by 9. So what does this become? So effectively it has become variance of x divided by 3. So what has happened here? If instead of 3 it was n, what is my formula now? I'm saying variance of mean x bar is equal to variance of x divided by n, where n is the number of points in the sample. Is this clear? And similarly, I can say standard deviation of x bar is equal to standard deviation of x by square root of n. Have you understood what has happened? So what has happened? My standard deviation has reduced here for the mean because I've taken up the mean. My data, when it was spread like this, will end up becoming narrower. And this is called the central limit theorem. Okay. Have you understood what has happened here? From the simple formula of variance, we are able to come up with something which is going to be of huge benefit for the whole of statistics. Have you understood what we have done here? We will look at this by simulation also, but mathematically you should be clear about it. If you understood, please raise your hands. By the way, you require to expand the whole thing again and again, is it? The panel every time you have to raise hands or type, because as Lavita was facing a problem of not seeing the screen, I assume that you guys are having it, or is it manageable? Is it easy to manage? Manageable. All right. Okay. So this is clear, right? So let's move ahead. So now the product of independent variables, which means basically the covariance is zero, right? I can say variance of x into y is equal to expected value of x into y square minus expected value of x into y the whole square, right? That's basically the concept, right? We say uh, uh, that's how we ended up calculating it, and so on. We can kind of keep on doing a lot of work here, but let's just look at properties of expected values. Expected value of c is c. And then if we say if x and y are random variables such that x is always less than equal to y, then for sure the expected value of x is also going to be less than equal to expected value of y, right? Because if I take the average of whatever the values are, the average is always going to be the less value, right? Linearity, expected value of x plus c is expected value of x plus a constant c. Expected value of a x plus by plus c is equal to a into expected value of y plus b into expected value of x and so on, right? Non-multiplicity, expected value of x into y is expected value of x into expected value of y plus covariance of x y. But if they are independent, what happens? This becomes zero. All right. Okay. So this much only is needed for our mathematical understanding of variance. Now, as we move ahead, we will have more things to do. Let's come back to our homework part one. Okay. Uh, so we're saying, so now let us look at this question. If x bar, notice x bar and y bar are comprised of n independent identically distributed random variables arising from distributions, the distributions have the means mu x and mu y, all right, respectively, and common variance of sigma square. So both of these distributions have a variance of sigma square. What is the variance of x bar minus y bar? Can you compute this? Come on, I would like you to calculate this. First, you compute the variance of x bar, and then compute the variance of y bar. So, what's going to be the answer? Come on. Come on. So, Lavita has answered, but don't look at her answer. And why? So, what is first of all going to be the variance of x bar? So, tell me this. What is going to be the variance of x bar? All right, but what's going to be the variance of x bar then? So, for, yeah, perfect, Kameshwar. So, what's the variance of x bar? Sigma square by n. Perfect, right? So variance of x bar is variance of x divided by n, right? Which is sigma square by n, right? So basically sigma square n by n plus sigma square by n, which becomes 2 sigma square by n. Okay, let me make it a little complicated now for you. All right, so this is fine. What if, let's look at the question here. I give you another question. Okay. Uh, what if I say I have uh, a distribution x which has variance given by sigma 1 square, and y has a variance given by sigma 2 square, and this has mu 1 and this has mu 2. All right, the means. Now I take n1 samples out of this and n2 samples out of this. Okay, so what is my variance going to be of x bar, which is defined by these n1 samples, minus y bar, which is defined by these n2 samples? So can you give me the answer for this now? I've changed everything here. Is the question clear? So earlier sigma 1 was equal to sigma 2 and n was equal to n2. Now I have these values changed. How do I compute this? So it will be sigma 1 square upon n1 plus sigma 2 square by n2. That is what Kameshwar is saying. Okay, fair enough. So that's Kameshwar's answer. What, anyone else? What's your answer? So this is going to be correct, right? Because what is it becoming going to be? It's going to be variance of x bar plus variance of y bar. And variance of x bar is going to be nothing but sigma 1 square upon n1 plus variance of y bar is going to be sigma 2 square upon n2. Is this clear? What is identical? No, if we, uh, identical. Mm, so it is just the variance, right? So there is no question of what do you mean by identical? What part has to be identical? Will this hold even if suppose this was a normal distribution and this was a uh, say chi-square distribution? X and y are IID variables. Perfect, right? So x and y are IID, but they need not be this. The distribution of x need not be the same as distribution of y. Okay, I don't think we need to check this, Lavita, right? Lavita's question point is that both of these x as well as y will have the same distribution, right? We said IID, right? But this IID is within x, and similarly IID within y. Okay, so there are two separate random variables with different distributions, and I can still have a common variance. I can have a variance if I was to subtract the two random variables, and that will still be given by this formula. Uh, Lavita, that's my understanding. If in case you have studied something more in depth because of your actuarial sciences, please let me know. Is the point clear? What am I? What point I'm making here? The rest of you also. So do x and y need to have same distribution, or can they have independent identical? No, distributions also need not be same. X can have a uh, uh, normal distribution. Y can have a chi-square distribution. So I don't think the distribution also need to be the same. What will end up happening is the distribution of their means will anyways end up becoming normal distributions because of the central limit theorem. So X and Y need not have the same distribution. I guess this might be new for you also, Lavita. Is this point clear to you guys? So let me move ahead with the next question here. Let X be a random variable having a standard deviation sigma. What can be said about X divided by sigma? So I've already answered it actually, unfortunately. Okay. So what's the correct answer here? So basically every random variable I'm dividing it by sigma, right? So assume that let's look at it this way. Let's simulate and see. All right. So we were doing random variables. I say R norm. So my data 1 is equal to R norm. So I'm generating 10 data points. Okay. 10, and let's say my mean is 4 and my standard deviation is 8. Okay. Or let's do 100 data points. Now if I was to uh, say take the standard deviation of data 1, what do I get? I get an answer which is close to this 8, right? Because this was the standard deviation that I had given it. All right. So if I keep on repeating this, let's say I say SD of data 1. Let's take some few more points. I'm getting 7.9, 8.2, and so on, right? So I'm getting different standard deviations. Now, what he's saying is, what if I was to divide each of these points uh, by the value? So which means I take this and then I say divide this by 8. Okay. So what will happen to the standard deviation now? If you notice, it's becoming close to 1, right? And 1 square is the variance. So basically variance is going to be 1. But that is what I've done through simulation. But even mathematically, if you were to actually do some algebra, you will come up with the same answer. Is this fine? And you have already done this. No. If a continuous density that, this is an interesting question. I think I will need Lavita's help in this question. Okay. Uh, how can they have common variance? Okay, Lavita has a question from the previous case wherein I said, we have to. No, it's not that they. How can they have common variance? When you add up two random variables, right? You have a new distribution happening. Oh, it was. I think what is confusing is it says common variance. It means that the variance of both of them is the same. It is not meant that they have a common variance. No, no, no. It just meant that okay, in that particular case, it so happened that the distributions are the same variance, but that is not the condition that is required. Okay, it just makes some calculations easier. For example, we don't need to do sigma 1 square upon n1 plus sigma 2 square upon n2. It's straight away sigma 1 sigma upon n, right? And then we just say 2 into sigma upon n, sigma square upon n. Okay, now look at this question. If a continuous density that never touches the horizontal axis is symmetric about 0, can we say that its associated median is 0? Interesting. So he's saying continuous density. What is that? So probability density function. So we're saying, so we have a, so 0 here. Okay. And the probability density function is such that it never touches the horizontal axis. So this is our horizontal axis. So it is, at the same time, it is symmetric. So well, it could be like this. It could very well be like this also, right? It doesn't matter as long as it doesn't touch the x-axis. Okay. So, or it could be in any other shape. Say it could be, right? So it could be this way. Anything as long as it doesn't touch 0. Okay. So if you're saying that it doesn't touch 0, what can be said about the can we say that its associated mean is 0? So can we say sorry, not the mean. Mean we know is 0, right? Mean is 0. What about the median? What about the median? Can we say that it is going to be 0? What is median? Basically, we're saying 50% of the values are lying below that, 50% above that. Huh? That's what's going to be the median. So can we say median is 0? As such, when you look at it, it looks simple, right? The answer is yes. But I was really surprised at the answer that has been given. They say it's a hard problem. The easy expression is that 50% of the probability is below 0 and 50% is above. So yes. However, it is predicated on the density not being a flat line at 0 around 0. That is why the caveat that it is never touches the horizontal axis is important. From this, what I make out is this. Say, even if we had a distribution which is something like this, let's say, I say I have a distribution which goes like this. Okay. So now, let's say it's symmetric around 0. Now the mean is going to be 0 because that's the center of mass. But what about median? Uh, no, it's not really. Asymptotic is typically tending towards infinity, right? That's what the asymptotic tends to be. Here it is tending towards 0. So we're saying that if this is how the graph is, what is going to be the median? Now, typically what happens is median is supposed to be a value, right? So I would be taking the uh, if I was to take the average, say this is the last value here and this is the last value here and everything else is 0, let's say, right? It touches the 0 here. Okay. Then I take the average of that, that will become 0. But as such, neither this value is on 0 nor this value is 0. Have you understood this? When we're talking about median, what is happening is we have values. So our values are on the x-axis, right? They're distributed like this. So say there are 20 values. So the 10th value or the 11th value has to be taken as the median. For simplicity's sake, what we do is we take the average of the 10th and the 11th value. But in reality, neither the 10th value nor the 11th value is going to be on the 0. Yeah, it will be divided into half at the vertical point for sure. But when if we take the average, that is fine. But typically median means one particular value, right? So median would be either 10 or 11, right? So it will never be going to be 10.5, right? So I think that's what they mean. That of course, mathematically we end up taking the median as 10.5 here, right? But as such, there is not a single median value. There are two values, and similarly, if the graph is the probability of getting a 0 is 0, right? That's what the probability density function is telling. That okay, this is 0, which means there is no value here, right? So how can I say that there is a median which is 0? Okay. So anyways, so this is not going to be of much importance or relevance as we move ahead. This was just so that you understand some of the basic concepts about variance, how it is getting added, etc. All right. So I think this much is enough for today. Okay. Let's kind of I need feedback. Were you able to follow the class? Was the speed good? Did you learn something new? How was it? Each of you. And how do you want to proceed further with the class? I mean, if all of you, because what happens is, typically if there's just one or two people, then it doesn't work out. So at least all of you guys from second year, first year are there, and it's just nice. So that the class, feels like a class. Otherwise, it's like a tuition. You know. So have you understood things? Whatever we did today? I think,
Yes,
can
sir.
we do one thing? Certain things you'll have to start following what I tell you now. Please take the quiz one today itself. The reason why I tell you to take the quiz one today itself is whatever you've done today, the quiz one will be relevant to that. Okay. So even if it takes you maybe 15 minutes, 20 minutes, finish it off. Your concepts will become better. Plus one deliverable will be done. Okay. All of you can speak, I guess, through the mic. I'm allowing all of you the mic rights, right? So, would you like to speak? Who would like to go first? Feedback on how it was. I mean, the best feedback is this. Do you want attending today's class? Does it give you priority to attend, data science classes in comparison to the bunks that you had been doing, or it doesn't? Very frank. Hello, are you guys there?
Yes, sir.
Yeah. So, whoever would like to go first? Kameshwar, Dipankar, Supreet, Lavita, Pratik, any of you? Go ahead and speak.
Hello, Bhaiya. Yes, the session was really good because after a long time I'm attending it. But yeah, if the sessions continue to be in the evening session, then definitely there will be no more bunking of it.
Okay. All right. So plus another okay. So only thing that I would like to add here is that another reason to bunking is when you have a lot of backlog. So please don't let a backlog happen. Like, so if you just finish the class, finish off the quiz one. Okay, right away. It was a bit fast for Supreet, but
Sure.
give me time. I'll improve. Okay, fine. So Supreet, just go through, the slides. Another thing that I would want you to do is Khan Academy. All right, little bit extra effort you may need to put. Towards the end, it was fast, but should involve practice from our side to get better. Okay, so what part was you not able to follow? Maybe when you think that it became faster. Right. So if you guys do things yourself, more important, yeah. So as we move forward, like so today we've done with homework one. By the time we have homework four, there are immense number of questions and everything that are there, which will make you understand things better. Plus Khan Academy, please see the videos there. Khan Academy really makes things very clear. Okay. So, in fact, today was just a kind of, rough idea about things. Probably go through the slides, go through the video lectures. Now, maybe if you go through the video lectures, it'll make more sense. Okay. So, and come up with questions. Maybe note down the questions. Okay. Hmm. Yeah. Yeah. Please go ahead and Lavita share what happened at IMC. Hello. Supreet, you want to share? Lavita, why don't you have the speaker rights? You should be able to speak through the mic. Your speaker is not working apparently.
Yeah, Supreet is here with me.
Yeah, Supreet, bolo.
Can you all hear us?
Ah, I can,
But
I can hear
yeah,
Dipankar so clearly. हाँ, Supreet bolo.
yeah, we are doing stats, but it would be. Can we? Can you teach us how to? I mean, we want to relate it. Like I was meant to give a presentation. I was having difficulty in finding stats from websites of different sectors and industries. But yeah, how can we use this statistical
Yeah, well,
Okay,
like for
analysis.
now we're doing
हाँ,
big data, right? I think Lavita
hmm,
had actually she had extracted these things. She had extracted market details and how much reach the online marketing strategies had got per company. She
hmm,
had done a
hmm,
sentiment analysis also.
hmm,
Could we like do whatever tools we have used in some of
hmm.
the classes? Could we focus on those kind of tools and how we can use them? So that what we can do is we can start using it in our presentations.
Right. You know that
That
what I noticed is there is a problem with you guys at SSU in general for everything. You guys don't want to. I mean, I don't know. It's a culture there The culture is that you don't want to spend too much time learning the fundamentals. You immediately want to jump into, I don't know, this has become a trend there. You want to jump into some outputs immediately or something directly applicable in the industry. And that's not happening just with our class. I see that it is invariably everywhere, whether it is finance classes, whether it is, marketing, everything. Know that unless you get your fundamentals in the classroom right, which are purely theoretical, okay, you will not be able to make anything out of even actual application data. Actual application data is just about giving name to a's and b's, like we are talking about x and y, right? uh, Same thing can be given some name. We can say x is, for example, the average height of people, or this or that. So that is all that is there to it. Focus initially on getting the fundamentals right with the numbers. Okay, once that is there, the transition will be very easy. The transition is just about labeling. So it's just the labels that are changing. So, but if you think, oh, how do I apply it there, maybe we should take those examples. Those examples will, what will happen with those examples is this. Let me just show you. For example, you have a huge story to read, right? Out of the story you have to pick up things. Okay, you pick things up, convert them into maths. All right, analyze and conclude certain things mathematically, then convert it back into the story, right? So what we are saying is, we say, okay, let us focus on this for now, these three parts. Once we are clear with this, we can easily do these parts wherein we have the story, we pick up stuff from it, we conclude it and convert it back into the story. Is this fine? So it is not, and this is the engine. So our focus has to be this. So if this is clear, all this will not be a big deal. So even if it was, say, I am guys, there, whatever presentation that happened, stats funda has to be clear. Once that is there, you will find it so easy to just pick up any data and deal with it. For example, if mean is clear to you today, right? What is mean? Expected value of the average, right? Then what do? You say, okay, let me uh, you can apply it in any situation. Let's say, uh, for example, what we did here, sample mean, right? We said it is divided by square root of n. What is that concept telling us? It is telling us, if we are to draw it as an example, uh, say, uh, I say, what is the uh, height of anyone in Shrish University? Okay, I want to find out the average height of anyone in Shrish University. So what I do is, I say pick up one person. Let's say it's Supreet. Supreet happens to be 6'1", and I say, look, average height, expected average height based on this data point is 6'1". Okay, and then I catch hold of Dipankar and I get it says 5'10", and I say average height is 5.10. Okay, and I say Kameshwar, so I say, okay, 5.9, so I say average height is 5.9 or whatever it is, right? But what if I do now is, I say, okay, let me take samples, five data points at a time. So I say, I take Supreet and I take Dipankar and I take Kameshwar and then I take Lavita and then I take Pratik and I take the average height, and let's say that comes out to be 5.7. Okay, but this now 5.7 is a better indicator of the average height of the whole university. Sirf Supreet, only Supreet was not, right? Why? Because this average height here now has got, the spread will be less, right? So because we have added up the five values, taken the average of that, so now suddenly my spread will be reduced by square root of n, which means square root of 5. Okay, because my data points are 5. So whatever the standard deviation I would have got when I had taken individual 5 values, versus if I take the average of the 5 values, would be related by a square root of n. And this concept comes from what we have learned today. So what is the ideal here? We first pick up the story, we convert it into mathematics, and then apply all the analysis as we are learning. So the key is to master things here. So that is what I would focus on, because if this is clear, these things are easy. Is this fine? Have I answered your question, Dipankar?
Yes.
Yeah. So in fact, I would strongly recommend all of you guys to follow the same thing for anything else also. If you're studying finance, if you're studying marketing, get your theory super solid, clear, and then you do the mapping. I mean, somehow I think there is this urgency to, start applying whatever you've learned. It is not going to work out unless your learning is solid, because you will end up with those situations where for example, today when we were talking about it, and Lavita said, what about x and what about y, they have to have a common variance, and I said no, theoretically it could be any distribution. Now you may not be able to understand what I'm talking about here, because I still have to do simulations. So what we do here is, we will not do look at industry example, but we will definitely do simulations. Simulations will help us understand things better, and that we are for sure going to do. So what are we saying, that whatever we do here, instead of picking it up from actual data, we simulate the data. That we will do. So I would really want you guys to change your approach. Become good with theory. You're good with theory, you will not make mistakes anywhere. Especially statistics. Statistics is a subject where you need to be really solid with theory. So for example, standard deviation, what's the big deal about standard deviation? You take any data points, right? You pick it up, let's say, I'll give you an assignment today. What you do is pick up different stocks. All right, so why do you even need to know journal and ledger? Simply because, like, so when you start applying, for example, what I'm doing today here is, this is my real situation here. Like, I have my Excel file here, okay? Uh, Now I decided that from 2015, I'm going to maintain my expenditures. So now my expenditures are split into different heads now. All right. So I have kitchen expenses, I have personal expenses, course expenses, house expenses. PTU is another project that's going on. I have expenses for that. You feel that way, but let me tell you what happens when you start. When you start using it, suddenly the theory will come to the rescue. So now I had been doing it. So now I structured it such that it was getting confused. Suddenly I remembered the ledger concept. You're talking about ledger. So I created individual ledgers. Once I created individual ledgers, I just created the summary. So once I created the summary, I suddenly had expenses for each of the people who are. See, what is happening is, for example, in the house expenses, there are two or three people who are contributing to their expenses. Personal expenses are only me. Kitchen expenses, again, five, six people who are contributing to it. PTO expenses, again, two, three people, two, three different people. So what is happening? I want to find out finally a summary wherein I say, okay, this is the, what was that? So I want to draw the summary. This was possible only because I understood the concept of ledgers. Are you getting it? I need to mute every one of you. Somebody's uh, also parallelly. Got it? So had I just jumped to, taking my care of my expenses, I would never have been able to structure it this way. Sorry, I'm my mistake. I was showing my timesheet on screen one. Here, look at this. All right. So I have different sheets here: kitchen expense, personal expense, course expense, house expense, PTU project expense, and then finally a summary. So now each of these are ledgers. Are you getting me? Now I had never drawn ledgers for my practical purpose ever. All this time it was just theory and whatever assignments had been done. And suddenly when I needed to do it, I could use it. So the idea is that you spend time with theory, understand it to the depth. You start questioning. Basically the point is that you don't question. That is why you don't learn anything from theory, right? So when you question why like this, and what if we do the other way, what if I do the exact opposite of something, what will happen? That is where the actual answer lies. Most of the times in your theory you don't ask these questions, and that is where theory becomes lack of learning. So start questioning your theory, because otherwise what happens is you will spend most of your time just doing this, in picking up and converting it into maths, and that was, hmm uh, Yeah, application of your theory is important. That is for sure there, right? But I would say we begin that once all aspects of theory are clear, because what happens is we begin with certain assumptions, and the moment you start applying something to real data, you have to be very clear about the assumptions, otherwise everything will go haywire. And therefore it is best that you completed a theory about a topic, and once you've done that, then you take up something in from real world, right? For example, in this also there is an assignment, right? And that assignment is mainly to do with simulation, but only once you have understood all these concepts you will be able to solve it very easily. So basically half cooked theory will not lead to, so basically let's say we have two situations here. You have so you have half cooked theory, then you have only theory, and then you have half cooked theory plus application, 100% theory plus application. All right. Now, what you end up doing most of the times is this in a B school, right? This creates problem. This is what you're doing in your engineering. All right. You're doing only theory maybe most of the times. Okay. Now, in fact, when you're doing this, you end up doing only this because you don't question. You have to question, so you at least are able to do this. If you are able to do this and then you add application to this, you will be able to, you are done. So the point here is, even though you're learning theory, you're learning half cooked theory. That is what is causing the problem, not theory by itself. So you're understanding where things are going wrong. Yeah. So basically questioning it. For example, right? Remember we talked about the chi-square test and the other day about something about the chi-square distribution of the normal this thing, right? All that is theory, right? So all that is theory, just that the yeah, in T distribution, right? All that is theory, just that how deep you go into the theory. That is basically how the scientific mind is. You go deeper into the theory, you will be able to do applications. Think of it. Let's look at the inventions, right? There are very few inventions which have been done by uh, let's I think once this discussion has started, let me talk about it. Let's say you could have done a diploma in engineering, diploma, right? Versus engineering, right? Say like somebody is a car mechanic, and this guy has done engineering, mechanical engineering. He says, look, I can't repair the car, but all the research and all the modifications in this car or all the advances in the car have happened because of engineering and not because of the car mechanic. Very rarely, yes, certain changes, but they are very outwardly. He would never be able to do anything which improves the mileage much. Most of it would have happened here. Why? Theory. So 100% theory is important, and then application. I mean, this is my philosophy. I believe that if you're super clear with your theory, you will come up with the applications very easily. Your applications part, you will not go wrong. Like for example, yes, application is interesting, that is for sure. Theory is boring, application is interesting. What we can do is, for example, today's case, right? I give you this question. What you should do is take up data from National Stock Exchange, okay, and find out the, say, each of you pick up some two stocks, all right, stock 1 and stock 2. Find out the mu and the standard deviation, mu and the standard deviation, all right. So you take this stock maybe for 5 years of data, right, daily data, okay, maybe opening, closing, or whatever, right? So you will have mu and sigma for each of these data, right? Then what you do is you take the monthly data. So you take say data for 5 years, let's say, all right. So you have individual data, you compute the mu and the sigma, and then you take the monthly data. What do you mean by that? Say we take Jan, Feb, March. All right. So you have 12 into 60 data points, right? Out of these for these 60 data points, you generate the mu and the sigma. All right. See if the sigma for the month has a sigma relationship with the sigma for the day. Right? From theory that we have learned today, sigma for the month should be approximately giving you, if I take the sigma, uh, basically I should take the mean, right? January mean, so I take those data points, right? Mu sigma. So this will be square root of 30, or rather 20, because you'll have 20 data points in a month. So you should get this. So whatever we did today, can you do this? Take this as a optional assignment. Pick up two stocks, pick up the data, calculate the mu and the sigma, then take the monthly data for each of the months, compute the average value. For those averages, you'll have 60 data points. Compute the average of the averages and the sigma of the averages. Is this a good enough assignment for you? Which is simple mu and sigma and central limit theorem, but at the same time something which will be practical. Have you understood the question? You will notice that you will see this kind of a trend. So you should have data points. How many data points? Around 250 into 5. So roughly about 120, 1250 data points you should have for 5 years. Maybe you can take 10 years. No. Not the day variance will not be greater than the month. The month you will take the mean. What you will do is, let me open a new book. You will, what you will do is you will have 1250 data points. All right. All the way from say Jan 1 2009 to, let's say, 31st December 2014. Okay, or maybe the whichever way, right? So basically 5 or 6 years of data. Now you have these single data points. I can find the average over this time period. At the same time, I can find the standard deviation over this time period. Now what I'm saying is, I take the averages for each month. So I take the average of first month. Okay, so I take the average of 20 data points, next 20 data points, next 20 data points, next 20 data points, and so on. These averages will give me how many data points? 1250 divided by 20, right? So I get something else. So I get another sequence. This sequence I take the average of. All right. I say mu of averages. Also for this sequence, which will have only these many data points, I also take the standard deviation. This standard deviation will be definitely less than the standard deviation that we got here. Kameshwar cannot hear me. Oops, what went wrong? Oops, Kameshwar lost connection actually. So you got it, no? So that is what you're supposed to compute. It'll be, yeah, I'm there. Okay, you got it back. Can you hear me, Kameshwar? So clear about the assignment? So basically just play around with data from the stock market and let's see what we get. Okay, so don't so that's it. Just play around with the standard deviation and the variance and the mean of the standard of stock market data for two different stocks, and then also do the same thing. We will have that, then add the two and see how it works out. And if we assume each of these data points as independent, just do an addition, right? So you do x plus y. So basically what you will do is you have each of these data points, so you have x1 and y1, right? So you add up all of them and see what you get, and take a variance there and see what you get. Is your variance getting added? Okay, so even the x plus y part you can do. So basically, you take the 1250 data points for x, 100 same data points for y, add the two of them, and see what you get for the added one, the mu and the sigma. Is there any relationship, or is it something nearby? Good. I think we have already created an assignment that you were looking for. Okay. So, what time do you want the class tomorrow? Around the same time? Good, I think. Yeah. Huh? So,